So, next topic natin sa about the network layer. So, nakita niyo yung presentation?
Yes po, ma'am.
Yan, okay. So, the network layers, ito yung patatlong layers sa ating OSI model. Yan. So magagamit yung network layer. Okay. So, for example, mag-send kayo ng email. Yan, kapag yung inyong friend ay nasa ibang country o nasa ibang city, yan, sasabihin ay nasa ibang network, kumbaga, sa malayo, hindi nasa isang area lamang. So, you need help yan to keep this message moving along the path. Yan. For sa inyong friends or the end device. So, to send the email or video or file to anyone who is not on your local network, so you must have access to the routers. Yan. So, to access routers, so you must use the network layer protocols. Yan. So, nadaan na natin yung switch, pagka-configure ng switch. So, ngayon ay sa router naman tayo. So, the module objectives, yes, we have 6 topics about the network layer characteristics. 5 lang pala. So 5 is explain how the network layer uses IP protocols for reliable communications. Yan, the IPv4 packets, ano yung mga major header fields in IPv4 and also in IPv6 packet. And then how host routes, so explain how network devices use routing tables to direct packets to a destination network. And also the router routing tables. So explain the function of fields in the routing table of a router. So sa router device tayo ngayon. Okay, so first, the network layer characteristics. Yan. So the network layer or the OSI layer 3 also provides services to allow end devices to exchange data across networks. As makikita dito sa ating figure, sa taas, so yung layer 3 and network 3, so the IP version Internet Protocol version 4 or IPv4 and the Internet Protocol version 6 or the IPv6. Ito yung mga principal network layer communication protocols. So yung mga other network layer protocols, so include the routing protocols, the Open Shortest Path First or the OSPF, and also the Internet Control Message Protocol or ICMP. So yung ibang other protocols in a network layer. Yeah, so the network layer performs 4 basic operations. So una, the addressing the end devices. So the end devices must be configured with a unique IP address for identification ng sa network. Also, the encapsulation, so yung network layer, so encapsulates the protocol data unit or the PDU yan, from the transport layer into packet. Ito yung dadagdag sa network layer. So, galing sa transport layer into packet. So, the routing, then the network layer provides services to direct the packets to a destination host on another network, sa other network, and also the de-encapsulation. So when the packet arrives at the network layer again, of the destination host, so the host checks the IP header of the packet. Yan. So in layer 3, yun, so yung encapsulation, so yung the segment. So galing sa transport layer, sa layer 4. Yan. So the IP encapsulation, So IP encapsulates the transport layer, yung layer sa taas, the segment or other data by adding the IP header. So makikita dito sa ating figure, so how the transport layer and PDU encapsulated by the network layer, PDU to create the IP packet. So it can use either an IPv4 or IPv6 packet and not impact the layer 4 segment. An IP packet will be examined by all layer 3 devices as it traverses the network, and then the IP addresses does not change from the source to destination. So NAT will change addressing, but will be discussed in the later modules. I mean, about the NAT. And so we have the characteristics of the IP. Yeah. So IP is meant to have a low overhead and may be described as connectionless, best effort, and media independent. So when we say connectionless, so there is no connection with the destination established before sending the data packets. Ganito. So IP is connectionless. So there is no control information needed, synchronization or acknowledgements. So the destination will receive the packet when it arrives, but no pre-notification are sent by the IP. So if there is a need for connection-oriented traffic, then another protocol will handle this. Yan, so ito yung connectionless kapag habang nag-send tayo ng letter. Yan, so yung makaka-receive. Yan. So, nung letter, so walang notification. So, may mag-notify. Yan. Kung may darating na message or sent. So, connectionless. Then next, the best effort. So, best effort naman, so IP is inherently unreliable. And so, because packet delivery is not guaranteed. Yan. IP will not guarantee delivery of the packet. Then IP has reduced overhead since there is no mechanism to resend data that is not received. And the IP doesn't expect acknowledgements. And IP does not know if the other device is operational or if it received the packet. Yan. So makikita dito sa ating figure na ito, illustrates the unreliable or the best effort delivery characteristics of the IP protocol. Yan. So kapag ka nag-send ng packet, yung ating host, PC, yung dadaan sa mga routers, so packets are routed through the network quickly. And so then some packets sa ating destination, so some packets may be lost in route. Then another characteristics is a media independent. Kapag sinabi natin media independent, so the operation is independent of the medium. Kung ano yung ginamit na media, kung ito ay copper, optical fiber, copper ethernet, or wireless. So, IP is unreliable, so it cannot manage or fix undelivered or corrupt packets. And then IP cannot retransmit after an error. And IP cannot realign out of sequence packets. And IP must rely on other protocols for this function. Ayun, so yun ang unreliable IP. So, and also media independent, din nga sabi kanina, so the IP can be sent over any media type. Copper, fiber, or wireless. So, makita natin dito sa ating figure. So, the IP packets can travel over different media. Yan, may wireless, may copper serial, optical fiber, or copper ethernet. Media independent. Ayan. Also, the network layer will establish the maximum transmission MTU. Ayan. So, ito yung major characteristics of the media, the network layer. So, the maximum size of the PDU. Ayan. So, ito ay yung maximum transmission unit. So, the network layer receives this from control information sent by the data link layer. And the network then establishes the MTU size. Yes. And then fragmentation is when layer 3 splits the IPv4 packet into smaller units. So, nagkakaroon ng fragmentation. So, the fragmentation so causes the latency. So, IPv6 does not fragment packets. Example is router goes from Ethernet to a slow one with a smaller MPU, or yung maximum transmission unit. Okay, so next, the IPv4 packet. Saan ba kayo?
Nandito pa po, ma'am.
So, raise your hands nga kung nandyan pa. Yan, tagdagan tayo. 40 na. Hindi tayo na-complete ng attendance. Meron ba sa inyo yung nag-drop na? Ba't parang kakaunti na? Okay, so next, the IPv4 packet or the Internet Protocol version 4. Okay, so the IPv4 is the one of the primary network layer communication protocols. And so the IPv4 packet header is used to ensure that this packet is delivered to its next hop and on the way to its destination and device. Yeah, so the network header has many purposes. So first, so it ensures that the packet is sent in the correct direction. Papunta dun sa kanyang destination. And also, it contains information for network layer processing in various fields. And the information in the header is used by all layer 3 devices that handle the packet. So the packet header fields, so the IPv4 network header characteristics, it is binary values, and it contains several fields of information. So nakita dito sa ating diagram, sa IP protocol header diagram, it identifies the IPv4 packet. And so from diagram is read from left to right, and 4 bytes per line, and then top down. The two most important fields are the source and the destination. Yeah, so from merong version, internet header length, and total length, and identification, and then meron time to leave or TTL, protocol, and then yung two most important field, the source IP address and the destination IP address. So ito yung mga significant fields in the IPv4. The function of the version, so this will be for V4 or version 4, so as opposed to V6 or the version 6, a bit of a 4-bit field. And the differentiated services, yan, so used for QoS, yan, or the quality of the service. And then the header checker, so ito naman ay to use to detect the corruption in the IPv4 header. And then we have the TTL or time to leave. Yan, so ito naman ay used to limit the lifetime of the packet. Yan. So, layer 3 hop count. So, when it becomes 0, the router will discard the packet. Yan. So, yung lifetime ng packet. Then, the protocol, meron mga ICMP, TCP, and UDP. And then, yan, the source IPv4 address and the destination IPv4 address. So, yung 32-bit source and destination address. Okay, so next, yan, the IPv6 packets. Yan, so nagkaroon ng IPv6 packets. Yan. So IPv4 is still used in today. Yan. So meron lang mga limitations and under sa IPv4 and merong advantages of the IPv6. So it has IPv4 has three major limitations. So una, the IPv4 address depletion. Yan. So IPv4 has a limited number of unique public address available. Yan. So approximately mga 4 billion IPv4 address. So the increasing of new IP-enabled devices, always on connection, and the potential growth of less developed regions have increased the need for more addresses. Yan. Then lack of end-to-end connectivity. Yan. So to make IPv4 survive this long, so private addressing and the NAT were created. So ang NAT ay yung network address translation. So ito yung technology commonly implemented within the IPv4 networks. And then the increased network complexity. Yan. So NAT was meant for as temporary solution and creates issues on the network. So as side effect of manipulating the network headers addressing. So yung NAT causes latency and troubleshooting issues. So ito yung mga limitation ng IPv4, Internet Protocol version 4. Yan. And then, nagkaroon ng IPv6. Yan. So, nag-start to noong early 1990s. So, yung IETF. Yan. So, developed the IPv6. Yan. So, and began regarding all the concern about the issues ng IPv4. Yan. So, began to look for a replacement. Yeah, so the improvements that IPv6 provides, increase the address space. Yeah. So the IPv6 addresses are based on 128-bit hierarchical addressing, yes, opposed to IPv4 na 32 bits. And then the improved packet handling. So ito ay mas simplified header with fewer fields. And then eliminates the need for NAT. So with such large number of public IPv6 addresses, so not between a private IPv4 addresses and a public IPv4 is not needed. Yan. So ito yung ano naman ng IPv6. Yan. So ito yung comparison ng IPv4 and IPv6 address space. Ito yung 1 billion. Ayan. So, there are 4 billions IPv6 addresses. Yan. And then, yung IPv6 naman, so there are 340 undecillion IPv6 addresses. So, dami. Mga IP address. Yan. So, ito naman yung IPv6. Packet header. Yan. So, yung one of the major design improvements of IPv6 over IPv4. Yan. So, ito ay mas simplified. So, but not smaller. So, the header is fixed at 40 bytes or octets long. So, several IP fields were removed to improve the performance. And some IPv4 were removed to improve performance, the flag, fragment offset, and header checker. Yan. So, ito yung ngayon yung packet header. So, mas kakaunti na yung mga fields kumpara dun sa IPv4. So, again, meron din pa rin version, flow label, the payload length, and also yung may nagkaroon ito ng hop limit, and syempre, ano pa rin yung source IP address and destination IP address. Yan. So, ito yung mga significant fields in IPv6 header. Yan. So, the version, so this will be for B6 as opposed to B4. And then we have the traffic class, so this for QoS. And the flow label, also the payload length. And then the next header, the mga protocols, so ICMP, TCP, UDP, and also the hop limit. Nagkaroon dito ng hop limit. So, ito naman yung replace ng sa TTL, sa IPv4. So, sa IPv4, yung time to leave, TTL, ito naman ay hop limit na napalitan dito. So, this value is decremented by a value of 1 by each router that forwards the packet. And then, yeah, also the source IPv6 addresses and the destination IPv6 addresses. So, ito yung 128-bit source and destination address. And so, the IPv6 packet may also contain extension headers. And so, the EH or extension headers, characteristics, and so provide optional network layer information, also optional, placed between IPv6 header and the payload, and may be used for fragmentation, security, mobility, support, and etc. And so unlike IPv4, so routers do not fragment IPv6 packets. Yan. So, may mga video dito sa NetAcad about the IPv4 and IPv6 packet header. Yan. So, kayo na lang mag-open ha. Panoodin nyo lang yung mga video para mas maintindihan niyo. Okay, next. So, how host routes. Okay, andyan pa ba kayo? Silder?
Yes, ma'am.
Yan.
Yes po.
So, yes nga muna diyan. Yan.
Yes po.
So, shout out muna. Okay? So, how host routes. Yeah, so with both the IPv4 and IPv6, so packets are always created at the source host. Okay, so, kung gagaling sa source. So, each host devices creates their own routing table. And then, another role of the network layer is to direct packets between hosts. Yeah, so a host can send packet to the following. So the first itself, yan, a host can ping itself and by sending a packet to a special IPv4 address. Yan. So in IP address, ito ng IPv4 is 127.0.0.1. Kung bakit tinatawag natin loopback interface. Pag sa itself, ito yung IP address ng IPv4. Pagka naman IPv6, so ang kanyang IPv6 address, yan, so itong dalawang colon, then 1. Ito yung loopback interface naman ng IPv6. Kung ipiping niya yung kanyang sarili. And then the local host, yan, so this is a destination host on the same local network as sending the host. So, yung source and destination host share the same network address of local host. And remote host naman, so ito naman yung destination host on a remote network. So, yung source and destination host do not share the same network address. So, kung makita din sa ating figure, so yung ating PC1, yung PC1 natin, connecting to a local host on the same network. Ayan. Connect siya sa local host. Then, kumbaga ito ay nasa isang network. Ito. And then, and to remote host located on the other network. So, yung remote host naman, yan, so nasa other network. So, mapapansin dito sa ating topology, so meron tayong dalawa ditong network. So, meron tayong router, isa yung local network, isang local network, isa lang yung kanilang network address, and so yung 192.168.10.0. And then yung other, nakakonect sa other interface, yan, yun yung other network or the remote network, remote host. Okay, so the source device determines whether the destination is local or remote. Yeah, so method of determination, so the IPv4, the source uses its own IP address and subnet mask along with the destination IP address. Okay, pag IPv6 naman, source uses the network address and a prefix advertised by the local router. Yan. So, ito yung in IPv4, meron siyang IP address and subnet mask. Ito ay 192.168.10.0/24. Yun ang network address. And ito yung mga address with IP address naman sa PC1. So, 192.168.10.10. Ito naman ay .15. And then we have .1. 192.168.10.1. So, local traffic is dumped up the host interface to be handled by an intermediary device. Then, remote traffic is forwarded directly to the default gateway on the LAN. Yan. So, para makapunta dun sa ating remote network o host. Yan. So, siya ay directly forwarded sa default gateway. Yan. So, ano yung default gateway? Yan. So, a router or layer 3 switch can be a default gateway. So, yung mga router natin. Ito, routers. So, ay default gateway. So, ano ba yung default gateways? Kumbaga ito yung parang pinaka pinto yan, pagpunta sa other network. So the features of default gateway or the DGWs, it must have an IP address in the same range as the rest of the LAN. It can accept data from the LAN and is capable of forwarding traffic of the LAN, and it can route to other networks. So if a device has no default gateway or bad default gateway, its traffic will not be able to leave the LAN. So, dito sa ating figure, so yung ating default gateway, so ito na tayong local network route. So, ito yung ating 192.168.10.0. So, kanyang, para yung PC1, makapunta sa remote network, so ang default gateway natin, itong router, so, yung may .1. So, 192.168.10.1. So, yun ang default gateway. Yan, papunta sa other network. So, the host will know the default gateway either statically or through DHCP and IPv4. So, IPv6 sends the DGW through a router solicitation or RS. Or can be configured manually. And DGW is static route, which will be a last resort route in the routing. Yan. So, ito yung default gateway. And the next, the host routing tables. Yan. So, meron tayong routing table. Example, it's sa ating router 1, PC1. Yan. So, routing for table for PC1. So, on Windows, so route print or netstat-r to display the PC routing table. So, ito yung command. So, para makita natin yung routing table sa Windows. So, netstat-r. The 3 sections displayed by these 2 commands. So, the interface list, yan. So, the interface, so all potential interfaces and MAC addressing, MAC addressing, and the IP or IPv4 routing table or the IPv6 routing table. Yan. So, ito yung makita natin sa routing table, sa host, yan, PC1. So, sa Windows. Okay, so next topic, yan, so last topic natin sa network layer. So, the introduction to routing. Yan. So, what happens when the router receives a frame from the host device? So, yung router so examines the destination IP address, ayan, of the packet and searches its routing table to determine where to forward the packet. Yan. So, yung ating R1, meron siyang routing table. Yan. Ito yung R1 natin. Ang route natin, meron tayong address na 192.168.10.0. So, ito isang network. And then, yung next hop niya is itong V0/0/0. So, dito. Daan. And then, yung another route, 209, another network, 165.200.224/30. It's another network ito. So, kanyang next hop, itong, or the exit interface, G0/0/1. And then, meron tayong 10.1.1.0/24. Ito yan. So, via router 2. And we have the default route. So, ang default route, pagka laging default, so yung 0.0.0.0/0. So, via R1. And so, ito yung route, forwarding decision sa router. So, the packet arrives on the gigabit Ethernet, 000 interface of router 1. Then the R1 de-encapsulates the layer 2 Ethernet header and the trailer. And so the IP router routing table. Yeah, so there are 3 types of routes in the router's routing table. Yeah. So the directly connected. Yeah, so ito yung mga routes automatically added by the router, provided the interface is active and has addressing. Yes, so makita natin sa yung figure natin. So, ito yung ating router 1. So, itong 192.168.10.0. So, ito yung mga direct connected. And also yung 209.165.200.224/30. Yan, so ito yung directly connected sa ating router 1. And then the remote, so these are the routes. The router does not have direct connection and may be learned. Yan. So, itong remote network natin, so itong 10.1.1.0, 10.1.2.0. Yan. So, yan ay remote networks and other networks. Hindi siya directly connected sa ating route 1 o router 1. So default route, so this forwards all traffic to a specific direction. So when there is not much in the routing table. Yan. So lagi merong default route. Okay. So the static route characteristics, so yung ating router can learn about remote networks in one of two ways. So manually o kaya ay dynamically. So pagka manually, so the remote networks are manually entered. Pagka naman dynamically, ito naman ay automatically learned using dynamic routing protocol. So pagka static route, so it must be configured manually. Also must be adjusted manually by the administrator when there is a change in the topology. It is good for small non-redundant networks and often used in conjunction with a dynamic routing protocol for configuring a default route. And so static, so manual, nilalagay natin o pino-configure yung ating IP address. And so, for example, ito yung ating R1 is manually configured with the static route to reach the 10.1.1.0/24 network. Ayan, so ito yung pagpakonfigure. So, ito yung paglalagay, ito yung command. Nilalagay natin yung IP address. Ayan. And then also the IP address of the next hop router. Ito naman, so padalawang figure, ayan, so nagkaroon yung R2, so nawala. So, if the route from R1 via R2 is no longer available, yan, so nagkakaroon ng new static route via R3. It would need to be configured. Yan, so static route does not automatically adjust for topology changes. So kailangan mo manual ilalagay kung ano yung sa aling router. Ito ay static routing. So, manual ito configure. Pag naman dynamic routing, so dynamic routes automatically discover the remote networks, maintain up-to-date information, then choose the best path to the destination, and find new best paths when there is a topology change. And so, dynamic routing can also share static default routes with other routers. Yan, okay. So, dito naman sa figure natin ito, so ay dynamic, so sabihin ay automatic. Yan. So, yung ating R1 and R2, so automatically sharing the network information, so using the routing protocol, the OSPF. Another protocol, the OSPF. Yan. And then sa pangalawang figure natin, yan, so R1 and R2 and R3 are using dynamic routing, also a protocol na OSPF. Yan, if there is a network topology change, yan, kapag nawala na yung R2, yan, so they can automatically adjust and find the new best path. Yan. So nawala yung R2, so pagdating sa R3 para makapunta sa destination, sa remote and network. So again, meron ditong video about the IPv4 router routing tables. Yan. Yes, ano meron dun sa routing table? Yan. So, the show IP route command shows the following route sources. Yan. Kapag kayo ay naglagay ng dito sa privilege mode, tatandaan niyo pa ba yung mga user mode, privilege mode? Ayan. So, in the privilege mode, so nandyan yung show IP route. Yan. So, yung show command sa privilege mode. Ayan. So, ito yung mga codes na makikita ninyo sa pagka-L. Ito ay directly connected local interface IP address. Then C, so ito ay directly connected network. And then S, static route was manually configured by an administrator. And then pagka O, ayan, so may OSPF. Pagka D, so yan ay EIGRP protocol. Yan. So this command shows types of routes. Yan. Pagka directly connected, sa example, so yun ay mga yung C at saka L. Yan. For example, yung sa C, yung 192.168.10.0. Ito yun. Ito directly connected in a gigabit Ethernet 0, G0/0/0. Also yung local. Ito naman yung dot 1. Ito yung dot 1. 192.168.1.10.1. And then the remote routes, yan. So yung matanindihan yung mga, yung O o kaya ay D. So ang O, ito yan. 10.1.0, 10.1.1.0. Ito dot 1 ito. Balik. So yun ay, sabihin ay remote routes. And we have the default routes. Yan, kung makita kayo ng mayroong S na asterisk, then 0.0.0.0/0. So yun yung mga default routes. Okay? Yan. So yun yung mga sa routing table. So para mas maintindihan ninyo, yan, malaman pagbabasa about sa routing table. Yan. So panoorin nyo na lang yung video. Yan. So we'll explain the information in the IPv4 routing table. Okay? Okay, so yun yung about the network layer. So yung mga routing tables, these static, dynamic, and the mga default gateway, and also the IPv4 and IPv6. Okay, so may natindihan ba? At konti in network layer. Okay,
Meron po, ma'am. Meron po, ma'am.
Okay, so what did you learn in this module? Okay, please read nga. Si Rizal, Babaw.
Hello, hello.
Yan, okay, go.
Babasahin ka po lahat.
Yes, yes.
Sige po. IP is connectionless, best effort, and media independent. IP does not guarantee packet delivery. IPv4 packet header consists of fields containing information about the packet. IPv6 overcomes IPv4 lack of end-to-end connectivity and increased network complexity. A device will determine if a destination is itself another local host and a remote host. A default gateway is a router that is part of the LAN and will be used as a door to other networks. The routing table contains a list of all known network addresses, prefixes, and where to forward the packet. The router uses longest subnet mask or prefix match. The routing table has three types of route entries: directly connected networks, remote networks, and the default route.
Okay, so yun yung about the network layer. Okay, may questions ba? Yan, so pwede tayong tumuloy sa next module, module 9. So konti lang naman ito. So bilis, atong topics lang. And then para next week, yung module 10, ito yung basic router configuration. So may activities tayo doon sa router. Okay? Present ko lang yung next module. Okay, so nakita niyo na yung presentation.
Kita po, ma'am.
Okay, thank you. Okay, so next module, so address resolution. So the objective, and module objectives explain how ARP and the ND enable communication on a network. Yan. So, patuloy yung topic natin dito. So, about compare the roles of the MAC address and the IP address and describe the purpose of the ARP and describe the operation of IPv6 neighbor discovery. Yan. So, may MAC and IP. Yan. So, ano nga ibig sabihin ng MAC? Nakada niyo ba ano yung MAC? Ano yung MAC? MAC tayo ng MAC. Ano nga yung MAC? Ano yung IP?
IP po ay Internet Protocol.
Yan. Let's cherish. Ang MAC ay Media
Access
Access
control.
Control. Ayun, Media Access Control. Kaya tayong MAC address at saka IP address. Yan. So, the MAC and IP destination on the same network. Yan. So, sometimes a host must send a message but it only knows the IP address of the destination device. So, IP lang yung alam nila. So, the host needs to know the MAC address of that device. Yan. So, but how can it be discovered? Yan. So, there are two primary addresses assigned to device on an Ethernet LAN. So, in layer 2 physical address, and then yung MAC address. We use for NIC to NIC communications on the same Ethernet network. And then the layer 3 logical address, so yung physical address, and the IP address, to use to send the packet from source device to destination device. So the layer 2 physical addresses are used to deliver the data link frame with the encapsulated IP packet from NIC to another NIC that is on the same network. Here. So if the destination in IP address is not on the same network, so the destination MAC address will be that of the destination device. Ganito sa ating example, we're using the simplified MAC address representations. So yung PC1, so wants to send a packet to PC2. So yung layer 2 destination, and the source MAC addresses, and the layer 3 IPv4 addressing would be included in the packet sent from the PC1. Yes, so dito yung destination and source MAC address. Also the IPv4 addressing. Yes, so destination, the source and destination. Para makapag-send dun sa PC2. Okay, so destination on the remote network. So when the destination IP address is on the remote network, so the destination MAC address is that of the default gateway. So ARP is used by IPv4 to associate the IPv4 address of a device with the MAC address of the device NIC. And the ICMP-v6 is used by IPv6 to associate the IPv6 address of the device with the MAC address of the device NIC. Yan. So, ito yung naman sa simplified sample, simplified MAC address representation sa remote network. So, yung PC1, so wants to send a packet to PC2. Yan. So, medyo malayo, nasa remote network or nasa other network. Kita ninyo. Yan. So, dahil wala siya sa local network, so the destination MAC address is that of the local default gateway of the router. Yes. So, magiging default gateway. Yan. So, we have the destination MAC address. Yan. Ito yung that's BB. And then the source itong AAA. And source natin, IPv4. So, tumagal dito sa 192.168.10.10. Ito yung source natin, yung PC1. And destination natin ay yung 10.1.1.10. So, PC2. Ang default gateway natin ay dadaan dito sa destination natin. Ito yung BB-BB MAC address. So, yung default gateway. Okay? Okay, next, DR. Yan. So, nga ba sabihin ng R? Sorry. Wait. Wala po. Okay, so the R. Okay, so if your network is using the IPv4 communications protocol, so the ARP or the address resolution protocol, yan, is what you need to map the IPv4 address to MAC addresses. Yan, so the ARP provides two basic functions. Okay, so una, resolving IPv4 addresses to MAC addresses and maintaining the ARP table of IPv4 to MAC address mappings. Yes, ito yung dito sa ating illustrations. So ito yung problem when sending a frame to another host on the same segment on IPv4 network. Yes, so okay, I need to send information to 192.168.1.7. So ito yung sa H4. But I only have the IP address. So I don't know the MAC address of the device that has that IP. Yan. So to send a packet to another host on the same local IPv4 network, so a host must know the IPv4 address and also the MAC address of the destination device. Yeah, so the destination device or the IPv4 addresses are either known or resolved by the device name. Yeah, so yung ARP or the address resolution protocol, so ito yung mag-determine the destination MAC address of a local device when it knows its IPv4 address. So yun yung function ng ARP. Okay, so other functions. So to send a frame, a device will search its ARP table for destination IPv4 address and the corresponding MAC address. If the packet's destination IPv4 address is on the same network, the device will search the ARP table yan, for the destination IPv4 address. And if the destination IPv4 address is on different network, that's ibang network, so the device will search the ARP table for the IPv4 address of the default gateway. Default gateway naman. And if the device locates the IPv4, its corresponding MAC address is used as the destination MAC address in the frame. And if there is no ARP table entry is found, yan, then the device sends an ARP request. Yan. Again, meron ulit tayong mga video din ha sa NetAcad yan para mas matindihan ninyo paano yung ARP function. Yan. Yan, for ARP request para MAC address. Panoodin nyo muna yung mga videos bago kayo magsagot ng module exam. Yan. Another videos, yan, over how an ARP request will provide a host the MAC address of the default gateway. Yan. And removing the entries from ARP table. So entries in ARP table that are not permanent and are removed when an ARP cache timer expires after a specified period of time. The duration of the ARP cache timer differs depending on the operating system. And the ARP table entries can also remove manually yan, by the administrator. Okay. And then, ito naman yung mga commands yan, in a Cisco router. So, show the IP ARP yan, to display the ARP table. Yan. So, in the privilege mode, yan, show IP ARP. And then sa Windows naman, sa PC, yan, para makita yung ARP table, so use the command ARP, yan, space dash A. Yan, so sa Windows, sa PC. Ito naman yung command para makita yung mga ARP table. And then on the ARP issues, yan, so ARP requests are received and processed by every device on the local network. So excessive ARP broadcasts can cause some reduction in performance, and ARP replies can be spoofed by a threat actor to perform ARP poisoning attack. Enterprise level switches include mitigation techniques to protect against the ARP attack. Okay, next, yan. So last topic tayo. About the IPv6 neighbor discovery. Okay, so may mga videos dito ha. Hindi ko na lang ipi-play. So, play ninyo ha para mas maintindihan ninyo. Okay, so, IPv6 neighbor discovery or ND protocol provides yan, the address resolution, the router discovery, and redirection services. And then the ICMPv6 neighbor solicitation or NS and neighbor advertisement or NA, so messages are used for device-to-device messaging such as address resolution. And then also may router solicitation and router advertisement. So ito naman ay used for messaging between devices and routers from router discovery. And then yung ICMPv6, so redirect messages are used by routers for better next hop selection. Okay, so ito yung address resolution, so IPv6. Yeah, so the IPv6 devices use ND to resolve the MAC address of a known IPv6 address. So the ICMPv6 neighbor solicitation messages are sent using special Ethernet and IPv6 multicast addresses. Yan. So, doon sa ating figure, so para ma-determine yung MAC address, and sa IPv6 address, so yung PC1, yan, sends ICMP-v6 neighbor solicitation message. Then, PC2. Ayan. So, yun yung about the neighbor discovery. Ayan. So, yun, mabilis lang. Okay, so, what did I learn in this module? Yan. Yan. So, para mas natindihan ninyo, panoodin nyo yung mga video. Hindi ko na lang ipe-play, ha? Sige, what did you learn? Charles Marasigan? Yes, so, ikaw na lahat magbasa. Okay, yan. So, that's all for today. Ayan. So, para sa matindihan, yan. So, bago nyo sagutan yung mga module quiz, again, panoorin nyo muna yung mga videos. Ha, mahaba pa naman ang time natin. Pang panood yung mga video. And then, sasagutan ninyo yung ating module quiz. Yung sa module 8, yung 8.6.2, at saka yung module 9, yung 9.4.2. And then, screenshots nyo ulit yung inyong score and then send sa Google Classroom. Okay?
Yes po, ma'am.
Wala nang questions? O may questions pa?
Wala po.
Yan. So, doon sa mga may mga kulang pang exam, module exam, bali 1 to 3, and then module exam 4 to 7, yan, dalawang module na tayo. Yan, so, pa-message na lang sa akin kung sino mga hindi pa kulang pa ng exam, and then kung ano yung module exam, para i-activate ko din ngayon. Okay? Exam lang tayo ngayon. Pa-message na lang sa akin. Okay, so kung wala ng questions, yan, so thank you for attending our class. Yan, so pwede na kayong mag-leave sa ating Google Meet and yan, panoodin yung mga video and mga exam. Take ng exam. Module quiz. Okay, so that's all for today.
Thank you po, ma'am.
Thank you po, ma'am.
Thank you po. Salamat po.